All right, welcome to the beginning of chapter 2, which is all about solving equations. Now, some of this will be review for you, some of from last year. Some of it will be new. It's good to take it all in and to really focus in on how we solve equations. And I have this one problem listed right here because really what we're doing when we're solving these equations is what you did back in, first, second, third grade um, when you filled in the box with what fits in that box. Maybe you did it later on in your schooling too, but this is really algebra. So you're just figuring out what goes in this box, and when added to 15, or added 15 to it gets you to 20. And you might be able to say, oh, that's 5. I know that. 5 plus 15 is equal to 20. Figuring out what's in that box, that's algebra. That's solving for an equation. And instead of having the box, oftentimes we are going to see variables. All right. So I want to start you off with something that you might remember seeing in class the other day, or maybe we didn't get to that yet. Either way, um, first of all, the difference between equations and expressions, because we've been working with expressions so far, and you know that are expressions are a mathematical phrase including one or more variables. So that would be an algebraic expression. I mean, numeric could have no variables. But a little example there is just a plus 9. It's just an expression, a plus 9, the number plus 9. All right, and the difference between that and an equation is really just an equal sign. So an equation is a mathematical sentence that uses an equal sign. All right, and you could think, you can still use that a plus 9 that we use as an expression above and just set it equal to 15. All right, that's an equation. You could say x minus 12 equals 14. There you go, that's an equation. Anything with an equal sign with expressions on each side would be an equation. So we're going to be working primarily with equations in this unit. All right. Next thing to note is inverse operations. Inverse operations are simply, if you know the word inverse, they're kind of opposites. So if you think inverse, you might think opposite. And when you think of inverse operations, we know that operations are, in math, are addition, subtraction, multiplication, and division. And really, the inverse operations are just things that simply undo one another or are the opposites. So if you think of addition, something that can undo adding 5 would be subtracting 5. So the opposite there, the inverse operation would be subtraction. And if you're going backwards, the inverse operation of subtraction would be addition because they undo each other. I'm guessing you can probably figure out from this that the inverse operation of multiplication, if you're multiplying, you can undo it by dividing. So that would be the inverse operation of multiplication. And then likewise, the inverse operation of division would be multiplication. So today we're gonna look at mostly just addition and subtraction and how we can use the inverse operations to help us solve for equations. All right. So you can see addition, and we're going to use subtraction to undo it. And then that brings me into the technical terms for how we can use the inverse operations, which are the properties of equality. This will help us prove that what we're doing is real. These are properties that are proven in math. And if you think of equality, you think of equal signs, of course. So if you want things to be equal, you still want to add, you can say, this is what the addition property says. If A is equal to B, so you just have one side equal to the other side, then A plus C equals B plus C. In other words, I really want you to focus in on, if you want to put it into words, if you add the same thing from both sides of an equation, and I should say to both sides of an equation, then they are still balanced. So I'm going to change this to 2. So if you have an equation that is set equal to each other, like a equals b, all right, so we can say a equals b. If you want to add something to, to both sides, if you want to add something to one side, let's say you want to add 7. In order to keep that balance, like you think of a balance, in order to keep that balanced, you have to also add 7 to the other side. Okay, that's just saying that you can do that if you want. To keep it balanced, though, you have to do it to both sides. So then you'd have a plus 7 equals b plus 7, and that is legal. Now the same thing goes for subtraction. It's kind of neat that you can do the same thing with subtraction. If a equals b, again, you have a equals b, and I can write that out over here, how we did it up there. If a equals b, there's our equation, then a minus c equals b minus c. Or in other words, if you subtract the same thing from both sides of an equation, they are still balanced. Right, let's say you wanted to subtract, you wanted to take 8 away from a. So we'll just say minus 8 here. Now it's a little bit lopsided. Now you have more on the right side than the left side, so you have to keep it balanced, and you have to subtract 8 from the right as well. And your new equation is a minus 8 equals b minus 8. Still balanced, it works. That is legal to do. And you'll see why that is really helpful in just a second. Okay, so make sure you have that down. Now, what I want to go back to is we're going to start looking at a couple equations. So the term isolate is something you'll hear a lot in algebra. Isolate the variable. In other words, getting the variable alone on one side of the equation. So you want to isolate. If you think of isolate, in football they call ISO. That means you're trying to isolate the running back all by itself. They do the same thing in basketball. If you want to isolate the guy with the ball, everyone else goes to one side, and then the guy with the ball is all by himself to make a move on his defender, his or her defender. All right, it's isolating to make something happen. So when we're isolating a variable in equations, we're trying to get the variable that we're trying to solve for all by itself on one side, and then we have solved for it. So it should try, you want the equation to end up looking like this if you're isolating for the variable. It should end up getting x equals 15, something like that. Getting the x all by itself there. So I'll circle the x is all by itself. M equals -3. There's another example. The m, you got the m all by itself. You isolated it on one side. Another example here would be y equals 0. Y, again, is all by itself on one side, so we solved for y. And then lastly, to isolate m, here we got m equals 8. Again, that one is all by itself on one side. Even though it's on the right side, it is by itself. And then 8 equals m, or m equals 8. So that would be isolating a variable. Now, let's practice this. Let's try using the addition or subtraction property of equality. Remember that said we could add or subtract something from one side as long as we do it to the other side, which is also called the additive inverse, to isolate the variable. All right, so we're going to try to isolate that variable again using what we can, what those properties are. So let's start with number 1. X plus 14 equals 17. Now you can probably say, well, x has to be equal to 3, because 3 plus 14 equals 17. But we're going to prove that using algebra. It's only one step. I only want to see this one, maybe 1.5 step, because this actually shows that you've proven it and shows that you can follow the steps. Because in the future, just later in this week, next week, we're going to have equations that are not this easy to solve in our head. So you need to know how to do it using the proper rules. And in this case, we can use the subtraction property of equality. If we want to isolate this x, I'll circle it or put a box around it. We want to get that, we want to leave that by itself on this side. since it's a positive x, we can get rid of this 14. So let's say we subtract 14. Remember, the inverse operation of addition would be subtraction. But in order to keep our equation balanced, we also have to do it to the right side of the equal sign. And if it helps, sometimes I like to just draw a line down here so we know that that's where the balance is in the middle. We have to keep it balanced. So we do minus 14 to the left, minus 14 to the right. When you do that, this cancels out. That's really nice. And you're just left with x over here, which is awesome because we just isolated that variable. And then we can figure out 17 minus 14 is 7 minus 4 is 3, 1 minus 1 is 0, so it is 3. If you notice here, we have our variable isolated, and it is set equal to the other side, and we are done. We solved for x. We isolated the variable and solved for x. So x equals 3 here. And give yourself a nice big smiley face because we solved for x. And this time we used the subtraction property of equality. Let's take a look at the right. We might use a different one here. All right, so m minus 12 equals 2. You might be thinking, what's minus 12 gets you to 2? And in your head, you might think 14. Oh, by the way, over here, we checked it. 3 was equal to x, and we proved it. X equals 3 up here. So we're going to say, I think it's 14, and we're going to prove it using algebra, because algebra is awesome like that. And what we're going to do is we're going to use the addition property of equality, because there's subtraction right here. Minus 12. So to undo that minus 12 and to isolate this variable, we're going to undo that minus 12, but we can add 12. All right? Now, but remember, drawing this line down here showing the balance, what you do to one side of the equation, you must do to the other side. So again, this is plus 12, so this should be plus 12. Keeping it balanced, remember that. All right, and again, the nice thing here, minus 12 and plus 12 cancels out, leaves you with m on the left side. And that is equal to 2 plus 12, which is 14. M equals 14, which is exactly what we got up here. So we give ourselves a nice big smiley face. We isolated that variable, and in so doing, we solved for m. All right. Here's a couple different ones. It just looks a little bit different. The x is in a different place for these two. But again, they're not too much more difficult. Still just about 1.5 steps. If you would like to try these on your own, please pause it and try them on your own. If not, we're going to go through them right now. Figure out which property we'll use to isolate the variable. So again, we are isolating the variable. All right, so if you look at this left one here, we're trying to isolate x. All right, so that's going to stay there. So what we have to get rid of on that side next to the x is that positive 17 that's added to it. Okay, so if you have a positive 17 plus x, see that's kind of a hard one if you're trying to go down to negative or going down to 12. It wouldn't be 5 because then you get to 22, so it might be negative 5. So we'll say it might be negative 5 here. Just check that. But let's do the algebra. So let's think. How do we get rid of a positive 17? Well, since this is addition here, we can subtract 17 from the left side. But remember, what you do to the left, you mustn't do to the right to keep it in balance. Minus 17 there. You are ended up with x on this side because, once again, these cancel out. What are you left with on the right side? 12 minus 17. So if you think of a number line, you start at 0, you start at 12, you go back 17. So here's minus 12. You still have to go 5 more back. You end up at negative 5. So total, we end up at negative 5. And, oh, the variable is isolated. And that means our answer is x equals negative 5, which is what we thought it might be up there. All right, another big smiley face because we solved something. Always feels good to do that. Now, if you wanted to check to make sure that's correct, if you really wanted to check, because sometimes we get an answer that we don't think is quite correct, what you do is you take that equation and you just evaluate for it, which you've done before. If you have 17 plus x equals 12, and you know that x equals negative 5, just take that little guy, x equals negative 5, and plug it in, or substitute it for the x. We have 17 plus negative 5 equals 12. 17 plus negative 5 is equal to 12, and 12 equals 12. So so 12 equals 12, which makes us happy. So we did it right. That just shows that we did it correctly. Okay? Now let's try one more. 10, oh, now we have the x on the right side. 10 equals 4.5 plus x. Now, like always, we're trying to keep this x all by itself, positive x all by itself. So, we want to get rid of this 4.5. And since it's positive, we can again use this subtraction property of equality. And know that if we subtract 4.5 here, that'll get rid of the 4.5. But to keep it equal, we also have to subtract 4.5 here. All right. Now the nice thing is this will cancel out, and you're left with x all by itself, or isolated. And then if you know 10 minus 4.5, so 10.0, I'm going to borrow from here, there, borrow from there, you get 9, you get 5, bring the decimal point down, 9 minus 4 is 5, so 5.5 equals x. Okay, 5.5 equals x, the x is isolated, so we are done. Big smiley face there. And again, you can check that. You can plug that in for your x, and you can say 4.5 plus 5.5 does equal 10, so we're good to go. That is just isolating the variable to solve for it. All right, so lastly, challenge problem. If you notice, something is different about this one. Something is different about this. This has a negative. It's subtracting an x. In all the other ones we had, this is a positive x plus x, positive x, and positive m. So the variables were all positive. In this case, we have a negative, or subtracting x. But we're not trying to figure out what minus x is equal to. We're trying to figure out what x is equal to. So what do you think we do? If you'd like to try this on your own, you can pause it and try it. Otherwise, I'm going to go through it right here. So what I would do, first of all, based on what we know about the addition or subtraction property of equality, let's just get rid of this negative x over here. And to do that, we can do the addition property of equality. We can add an x to both sides. All right, but just know that you have to do it over here as well. You add that x over here, because we don't want the negative x. We want a positive x. So you're left with, if you do that, this cancels out here. You're left with 12 equals, you can say negative 7 plus x. All right, there we have our positive x on the right side. Okay, and now we're in business. So what we're going to do next is try to get the x by itself. So that would be right here. Let's get that x by itself. And to do that, we got to get rid of that negative 7. And we're going to use the additive inverse, or the addition property of equality here again. So we will add 7 to both sides. Bring this down farther. Another little step here. Add 7 here. All right, just keeping the thing balanced and trying to get that x all by itself. So when you add 7 to both sides here, these cancel out. Negative 7 plus 7 is 0. So those cancel each other out. They're inverses. 12 plus 7 is equal to 19 is equal to x. And the x is isolated. We're done. X equals 19. Smiley face. But if you want to check it, you can always go back and say plug it in, right there. say 12 minus 12 minus 19 equals negative 7. We'll check 12 minus 19 is equal to negative 7. So that means we are good. Negative 7 equals negative 7. They're the same. So that is how you would do it if you had subtracting an x or a negative x on one side. You want to get it equal to the positive x. All right? So I'm going to leave you with two problems. I want you to try these two on your own. The first one is just using your properties. And the second one, well, you might have to do one extra step here before you can use those properties. All right? So try these and bring your answer and the work shown to class tomorrow, and we will talk about this at the beginning of class. All right, have a great day.